Hello everybody and welcome back to another Algebra 1 video. Today we'll be continuing lesson 9.4 with its extension on choosing a solution method to solve quadratic equations. In our previous lessons, we've been learning different ways to solve quadratic equations. For today's video, we won't be learning any new methods, but we will be looking at different problems and seeing which method would work best to solve it. I'm going to briefly go over the 5 different methods that we've learned and explaining when it's best to use them. For factoring, we'll usually use it when the equation is easily factorable. So this means you can look at an equation and easily think of 2 factors that you can factor the equation with. You do have to take into account that some equations are not factorable or they're just very difficult to factor, especially when your answers turn out to involve square roots or half fractions. So only use this when you can easily think of 2 whole number factors. For graphing, it's basically the same situation. You only want to use it when you can find exact values easily. Again, if you have square roots or fractions for your answers, then it would be really hard to visualize that on the graph. Additionally, graphing is a pretty tedious process, so if you do have the freedom to use another method like factoring, I would try to stay away from graphing. To use square roots, you're going to be solving equations in the form x squared equals d. Most of the time, this isn't possible, especially if you're trying to solve quadratic equations that are trinomials. So using square roots can't be used for certain equations. As for completing the square, it's most best used when your a value equals 1 and your b value is even. Previously, we have done problems where neither of these conditions are met, but I would recommend only using this method when the conditions are met, otherwise calculations might get a little difficult. Lastly, we have the quadratic formula. The nice thing about the quadratic formula is it can be used for absolutely any quadratic equation, and it will always give you the exact solutions if it involves, let's say, a fraction or a square root. I think that it's the best method for when the equation is not easily factorable or when the numbers involved are large. I often refer to the quadratic formula as the last resort method. So if any of the methods that you're trying don't seem to be working, I would go ahead and use the quadratic formula. Let's take a look at our very first example. We're going to solve x squared plus 8x plus 12 equals 0. We can use any method that we would like. For method 1, I'm going to go ahead and use completing the square since our a value is 1 and our b value is even. Remember that with completing the square, your goal is to substitute your c value so that you can make it a perfect square trinomial. So I would subtract 12 from both sides to get rid of the c value, and that would give me x squared plus 8x equals to negative 12. Now to find the c value that you're going to substitute in, it would be your b value divided by 2 squared. In this case, our b value is 8. So divide 8 by 2, that would give you 4, and then square 4, which just equals 216. Now that we've found our c value, we can go ahead and add it to both sides of our equation. So this would be x squared plus 8x plus 16 equals to negative 12 plus 16. Now you can go ahead and simplify your equation. Negative 12 plus 16 would just be 4, and as for your trinomial, you want to factor it into a squared binomial. So remember that the basic format is x plus or minus a value, and then squared. Whether it's adding or subtracting, you'll know whether your value is positive or negative, and in my completing the square video, I recommended a shortcut. The way you find the value that you're either adding or subtracting is just by taking half of your b value, in this case 8. This would just be 4, and since our value is positive, it would be x plus 4 squared. And that's how you simplify it. So now that your equation is simplified, you can go ahead and solve for your x value. First thing I want to do is I want to isolate x by getting rid of this squared. The inverse of squaring something is to square root it, so I'm going to square root both sides. By square rooting your x plus 4 squared, your squared gets eliminated, and now you have x plus 4 equals to the square root of 4, which is just plus or minus 2. And now that you simplified that, you can isolate x by subtracting 4 from both sides, and that would give you x equals to negative 4 plus or minus 2. Now all you have to do is evaluate this to find your two x values, one for the plus, one for the minus. So if you were to add 2, negative 4 plus 2 would just be negative 2. And if you were to subtract 2, that would give you negative 6. So your two x values are negative 2 and negative 6. We're going to look at the exact same problem, except we're going to use a different method. In this case, our equation is actually easily factorable. So we want to think what two numbers multiply to the last number 12, and what two of those same numbers add up to the middle term 8. So if I'm thinking of factors of 12, I have 1 and 12, I have 2 and 6, I have 3 and 4. Looking at these factors, 2 and 6 would add up to 8, so I'll go ahead and use those two. Now we can go ahead and factor it out. It would be in the form x plus or minus a value, and then another binomial of x plus or minus your other value. In this case, both of our values are positive, so it'd be x plus 2 times x plus 6 equals 0. And now using your zero product property, you can set up each of your expressions to 0 and then solve for x. So it'd be x plus 6 equals 0 and x plus 2 equals 0. And then all you have to do is subtract 6 from both sides to find the x value here, and then subtract 2 from both sides to find the x value there. And again, you'll get that your x value equals to negative 6 and negative 2. And all our answers are the exact same, even though we're using different methods. The last method I'm going to show you is graphing. As you saw in the previous two methods, our solutions are exact values, so graphing would be a good method to solve. Remember, whenever you are graphing quadratic equations, first thing you want to do is find your axis of symmetry, which is x equals to negative b over 2a. The axis of symmetry is basically just the x-coordinate of your vertex, so once you find it, you can go ahead and plug it back into your original equation to find your y-coordinate of the vertex. So again, our axis of symmetry is negative b over 2a. Substitute your b value, which is positive 8. This would just be negative 8 divided by 2, which is negative 4. Now that you've found the x value, plug it into your original equation to find the y value of your vertex. So this would be negative 4 squared plus 8 times negative 4 plus 12. So negative 4 squared just simplifies to positive 16. And then this would be plus negative 32, and then plus 12. 16 plus negative 32 is just negative 16 plus 12, which equals to negative 4. So the y value of your vertex is going to equal to negative 4. Once you've found your vertex, you can go ahead and graph it on your plane, and now we can graph your other points. If you remember from my video on how to solve quadratic equations using graphing, you'll know that the shortcut to graph any quadratic equation where your a value is 1 is to follow this pattern of going left 1 unit and then going up 1 unit, going right 1 unit, and going up 1 unit. Then you can go ahead and graph your 2 points there, and then you can go 2 to the left and then up 4, then 2 to the right and up 4 again, and then graph those 2 points. I would recommend graphing until you hit the x-axis, and once you have, you can go ahead and draw your curve. Now that we've graphed our equation, we can go ahead and look where our x values are. In this case, our parabola actually intercepts the x-axis here at -6 and also at -2. So again, your two x values are -6 and -2. Here is our next problem. We're going to solve x squared minus 10x equals 1. In this case, our a value actually equals 1 and our b value is even. Additionally, our c value is already on the other side of the equation, so we can substitute a new one using the completing the square method. So remember, to calculate your c value, it's going to be your b value divided by 2 squared. In this case, our b value is -10, so -10 divided by 2 is just -5 squared, and that would equal to 25. Now that you found your c value, you can go ahead and add it to both sides of your equation. So it'd be x squared minus 10x plus 25 equals to 1 plus 25. I'll go ahead and simplify our equation. 1 plus 25 is just 26. And then factor your trinomial on the left side. Again, remember your format is a squared binomial, so it's x plus or minus a value squared. Shortcut to find the value that you're subtracting or adding is by taking half of your b value, which is -10. -10 divided by 2 is just -5. So you'll be subtracting x by 5, so this would be x minus 5 squared equals to 26. Now that you simplified it, we can go ahead and solve for x. First thing I want to do is get rid of this squared right here, and the inverse operation of that is just by taking the square root. So take the square root of both sides, and by doing that you would cancel out the squared right here, and that would give you x minus 5 equals 2 plus or minus the square root of 26. Square root of 26 can't simplify to anything, so you can just go ahead and leave it as square root 26. And lastly, to solve for x, you just have to isolate it by adding 5 to both sides, and your final solution would be x equals to 5 plus or minus square root 26. Again, usually you would simplify this, but since we have a square root that we can't simplify further, this would do as a solution. Here is one more example for us to try. We're going to solve 2x squared minus 13x minus 24 equals 0. The first method I want to try is factoring. And as you see here, our a value is not 1, so we're going to have to use a different method to factor. I'm going to use the AC method. And I'll go ahead and show you how it works. The very first step you want to do is to multiply your a value by your c value. In this case, you would multiply 2 by -24, and that would give you -48. Now that you found that value, you want to think of factors of -48 that would give you -13. Thinking of factors of -48 that give you -13, we know that one of our factors has to be negative. So we could have positive or -1 and positive or -48. That probably wouldn't give us -13 though, so let's go ahead and keep looking. We could have +2 or -2 or positive or -24. Again, that probably wouldn't give us -13, so the next one would be positive or -3 and positive or -16. And actually this might work. If you multiply -16 by +3, that would give you -48. As for adding, if you add -16 to +3, that would give you -13. So now that you found the two factors you want to use, -16 and +3, you want to replace your middle term, negative 13x, with these factors. And if this sounds a little bit confusing, I'll go ahead and show you how it would look like. So you would replace negative 13x with negative 16x plus 3x. And if you look at this new equation, we have 2x squared minus 16x plus 3x minus 24. And you see these are the two factors that we just found. And if you were to replace, or if you were to simplify negative 16x plus 3x, that would give you negative 13x. So these two equations are basically still the same. Now you have to group two of your terms together. In this case, I would group 2x squared minus 16x and 3x minus 24. And I recommend when you're grouping that you try to be strategic about it and make sure you're grouping two terms that would share a greatest common factor. Now, if you group 2x squared minus 16x, you want to find the GCF and factor it out. Remember that the GCF is the greatest common factor. So between 2x squared and 16x, that would be a 2 and an x. And if you factor out a 2x from this expression, that would give you x minus 8. You can do the same for 3x minus 24. The GCF in 3x minus 24 would just be a 3. If you factor out a 3, that would leave you with x minus 8. And notice that the expressions that are inside the parentheses are the exact same for both 2x squared minus 16x and 3x minus 24. You always want to make sure that your expressions that are inside the parentheses are the same, because this is going to be one of the factored expressions in your final factored form. So you can go ahead and write x minus 8 down, and the other factored expression is going to be these GCFs that you factored out. So in this case, it would be 2x plus 3. And then you can go ahead and set it to 0, since that's what your original equation was set to. And this is your final factored form. All you have to do is set each expression to 0, and then solve for x. So if you set 2x plus 3 to 0, you would subtract 3 from both sides, and then divide by 2 to isolate x. So you would get x equals to negative 3 over 2. As for x minus 8 equals 0, all you have to do is add 8 to both sides, and you would get that x equals to 8. And those are your two solutions for this quadratic equation. X equals to 8 and x equals to negative 3 over 2. We can also solve this equation using another method. Now, looking at the equation, it would be difficult to use methods like completing the square because our a does not equal 1 and our b isn't even, so calculations might get a little bit difficult if you try to use completing the square. We can use quadratic formula if you decide not to factor. So first thing you want to do is identify your a, b, and c values. Remember that the format of a quadratic equation, whenever you're trying to solve using the quadratic formula, must be ax squared plus bx plus c equals to 0. In this case, our equation is already set to 0, so all we have to do is find our a, b, and c values. Our a value would be 2, b value would be negative 13, and c would be negative 24. Once you've found those, you can go ahead and plug them in to the quadratic formula. Remember, the quadratic formula is x equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. All you have to do is plug in your values. So you would have negative times your b value, which is negative 13, plus or minus the square root of b squared. Again, your b value is negative 13, so this would be negative 13 squared, minus 4 times your a value 2 times your c value negative 24. And that would be all over 2 times your a value, 2. Once you've plugged in all your values, you can go ahead and simplify. So first, I'll go ahead and simplify negative times negative 13, which would just be positive 13. As for the calculations inside of your square root, negative 13 squared is just positive 169, and then minus 4 times 2 would be 8 times negative 24. 8 times negative 24 would give you negative 192. So in the square root, you're doing 169 minus negative 192. When you're subtracting from a negative, this would turn into an addition sign. So this is just 169 plus 192. And that would give you square root 361. And for the bottom, 2 times 2 is just 4. Now that you've simplified this, you can go ahead and further simplify square root 361. 361 is actually a perfect square, and if you take its square root, it would be 19. So you would have 13 plus or minus 19 over 4. Now all you have to do is find your two x values, one for the plus and one for the minus. So you can do 13 plus 19 over 4. You can also do 13 minus 19 over 4. 13 plus 19 would give you 32. 32 over 4 just equals to 8. So one of your x values would be 8. As for 13 minus 19, that would be negative 6 over 4. And negative 6 over 4 can reduce by a factor of 2, which would be negative 3 over 2. And that is your other x value. And these are the exact same values that we got when we factored the equation. So your final solutions would be x equals 8 and x equals negative 3 over 2. That is it for today's video. Thank you so much for watching. If you have any questions about the problems that I do in these videos, please feel free to reach out to me via email at kaylin.david24@gmail.com. Please make sure to like and subscribe if you enjoy the content. As always, all information regarding additional practice, lesson requests, and tutoring inquiries will be linked down below in the description box. Again, thank you so much for watching today's video, and I hope to see you in the next one.